All right, good afternoon, folks. Here it's 4 p.m., but my body thinks it's 9 a.m. and that I've spent the night up without sleep, so bear with me. So I'm part of a small team. We've been working with Clojure for about 6 years now, and we build web applications for clients, but mostly for ourselves. We have a number of products that we work on. And I think we have about, 10 to 14 active projects in production that our team manages and works on and develops. So we're quite sensitive to code complexity because there's a kind of very high code to person ratio. Today I'm going to talk about a very small problem, but quite common when building web applications, and explore a bit about how the Clojure community or Clojure programmers tend to approach it. And then later, muse a little bit about how this approach that I'll talk about is part of a broader trend and what it might lead to soon. So your typical web application is really kind of a glorified front for a database. I mean, there's other systems usually behind the scenes, but fundamentally, we care about managing some data. And we kind of structure a web application with, the database in front of it. You might have some namespace that, wraps the database, and then some handler that sits in front of that so that you can receive requests from your client. Now, the handler supports various routes, and each of these routes probably has maybe a one-to-one mapping with some database functions, and those might result in some SQL or some transaction that they call. Each of the handlers is pretty simple. It's basically, most of the time, it's basically just routing some verb and some HTTP path to some database operation. But this isn't, how things actually look in a real system, because we also need to check that the parameters are there. Like, we can't trust anything that the client gives us because it's coming from an insecure domain. So we have to check for parameters. We have to check that they're the right type. We have to ignore anything else that the client might be sending to us because our underlying parts of the system might use that information in various ways. So we need to make sure that only the right things are being passed in. We have to coerce things from certain types to others, from JSON to Eden, for example. We have to check that a user is authenticated. We have to check that the authenticated user actually still exists in the system. We have to check that the user is allowed to do the thing that they're trying to do. And we have to check that the thing they're trying to do is allowed for them to do at the time they're trying to do it, given the rest of the system. And so our handlers in practice end up looking more like this. And even this is kind of abbreviated, I'd find. I was trying to come up with the simplest thing to fit on a slide. But so all of these different things that we have to do are necessary for a correct and a secure system. And I occasionally get asked to audit other people's code at other companies and our own code as well. And I don't think I've ever found a system where there wasn't some kind of severe logical bug due to them missing one of these constraints. So implementing them like this, all ad hoc, is very error-prone and becomes difficult to manage. And you have to remember, okay, which actions does this new constraint apply to? Have we remembered to put it in all the right places? And all these concerns, coercion, authentication, security, etc., are all coupled together in this one thing, in this one place, the handler. Which works, and in small projects it's fine. But whenever you have to change something, it becomes hard. Like, what if, for example, now you have to also support WebSockets? All of this stuff is so entangled with HTTP that it can become hard. And how do you test this? It's all just, effectively, all you can do is do an integration test and send in some HTTP and check that it gives you back the right string. So I call this situation fat handler, kind of reminiscent of like fat model or fat controller in object-oriented systems. And I don't think it's a great kind of situation to be in. So perhaps we'd like to achieve some semblance of separation of concerns so that our handler isn't doing all these things, and factor out some of the behavior. Now, middleware or interceptors can definitely help in some situations like coercion. We can kind of, in general, just detect what's coming in and coerce it to the things that we think that we're going to expect. But there's a lot of things that are event-specific or like route-specific that we can't just magically put into one piece of middleware. So a common thing to do in this kind of situation is to split the responsibilities and maybe extract out an event layer. Now the handler is only taking care of the HTTP stuff, routing, input coercion, output coercion, and maybe user authentication. It's the one that has to figure out how to turn cookies into users. And the event layer does everything else. But there's still a few complaints if we do this. Now, every time we add a new layer, we tend to have more things to do every time we want to add a feature. We want to be able to do a new kind of event, probably a new function that needs to be called in the database, and another transaction that needs to be called. And if you're doing interesting stuff in the front end, then probably you'll have that same thing being called in the front end to update the front end state. And so for every little feature you add, you end up doing it in 6, 7 different places. And even if you look into one of these events, they tend to still be doing a lot. So I mean, it looks almost the same size as the handler before. And so something that I've seen Clojurists do, and in a number of talks you kind of get a passing mention when they show some of their code, is to take one of these functions that's doing all these things and kind of blow it up and put it back together into declarative, data-driven maps, or event maps. So for example here, it's that same thing and split out into giving an ID, the parameter declaration, the conditions that we were checking, and the side effect that we wanted to run. And then, given this data object, we would have some dispatching function that would end up putting all these things together again and checking the parameters, checking the preconditions, and then running the effect, just as before. So why do we think this is better? What does this data-driven approach give us over having the plain function? Previously, we had a tremendous amount of implicit semantic information, all of these different concerns trapped within this one function. And all that you can really do with it, with a function, is call it. But by breaking it up, we now have a much clearer place to put different things. We can come up with different concerns if we want to. We can come up with domain-specific syntax for each of these concerns. And this results in something that's typically much easier to work with and harder to make mistakes. But even more importantly, we are now free to remix these pieces as we see fit and to do new interesting things with them that we wouldn't have been able to do with an opaque function. For example, if you're not a fan of keyword-based dispatching, you could write a macro that takes these events and converts them into an actual function for you to call in other parts of your system. You could use this data and generate some rich documentation about your API. Or generate an entire RPC interface if you're working with a kind of trusted client, trusted server scenario. Or maybe you can do what Amazon does and take these kind of event objects and then generate the libraries for the various languages that interact with AWS. So you have a declarative way of describing the things that your system can do, and then you can generate the libraries to do those things. So that's just a taste. I'll go through a few more examples in a bit. But the important idea is that we had something opaque and turn it into something transparent and fungible that we can work with. Now you might be there sitting thinking, ha, you've just created objects. This is a functional programming conference. What are you doing? And in some ways we have, maybe, in that we have this kind of grouping of various things. But it's not like the language, Clojure, is forcing us to do everything with objects. And these things aren't mutable at all. They don't have state. And more importantly, because they're just data, they have no behavior. There's no baggage and implicit kind of behavior around them. And they're very fungible and easy to kind of rearrange and work with. So this kind of data-driven approach, if you want to learn more about it and why it's good and stuff like that, there's a very good talk called Transparency Through Data by James Reeves, also called Weavejester, that I recommend. But in general, I think this idea of data-driven events is a good thing, and I recommend kind of using it in your projects, and you don't have to necessarily use Clojure to do that. And it's easy enough to do yourself. You can imagine it's not a lot of code to take one of these objects and then trigger the preconditions, check the parameters, run the side effects. But it's not completely trivial, especially if you keep adding on functionality. And so I thought it might be a good idea to have a library for the community to kind of build around and something to recommend to new Clojurers. So today I'm releasing Tada, which just implements that data-driven dispatcher. And we can take a very quick look at how that works. So in Tada, you describe events. You give them an ID, parameters, which are right now just using data specs, which is a way of kind of doing optional specking. Conditions, which are like preconditions on functions. You can give them an array of a function, typically a predicate, to run, and it returns true or false. You give it an anomaly, a keyword. If you haven't heard of anomalies, they're a thing that Cognitech came up with like last year or 2 years ago. And basically, it's a very small collection of a few keywords that are used to describe typical anomalous behavior. So they're kind of like, the HTTP status codes, 500, 400, 300, but kind of more semantic and domain agnostic. And they kind of different keywords entail slightly different things, like, oh, you can retry this, or no, you can't retry this event, or et cetera. And then the effect is the side effect that you want to run. You register these events, and then you can call them with do. And you kind of just give the keyword of the ID and the parameters. So it's sort of, if you've worked with reframe, it's sort of like reframe on the back end, but with some more stuff added on, as I'll explain. So when you do this, what you get right now is something that checks the parameters for the types, checks that they exist, checks that removes any parameters or things in those objects that are not supposed to be there. It checks all the preconditions, and then it runs your effect. And honestly, it's really not much right now. Like, the code behind the scenes is probably like 20, 30, not even lines of code. And like I said, you can slap it together yourself, but hopefully it's something that the Clojure community can kind of build around and do interesting things with. So what are some more interesting things we might be able to do? You could derive a ring handler from that information and then just pass it to your router, because you have all the information you need now to do that. Now, maybe you do have to do some special things, and in that case, you can wrap the handler with your own handler. Or you can take this information and just deploy it to AWS using AWS Lambda. Again, you probably have enough information to do that. Now, these two examples, well, the first one exists, but the second one doesn't exist yet, but it could be something that was possible. On the front end, we could have a function now that checks whether or not an event is allowed, like whether or not an event would work if we tried it, or whether it's allowed, and use that to determine whether we should show the interface that decides to do that. So you no longer have to check, oh, is this user an admin, and therefore they can do this. Because therefore, when you do that, you have all this implicit logic about, oh, admins are allowed to do this, peppered throughout all of your interface. Instead, now you have that information in one place on your events, and you can make use of that to manipulate your UI. Or maybe you derive an AJAX function that knows exactly where to go and what to do, and it's smart enough that it knows which anomalies it can retry and which anomalies it can't. Or even derive, if you're using reframe, an entire event handler that knows how to update the state and maybe trigger some AJAX. And these examples Haven't been implemented yet, but they could be. And there's still lots to figure out within the library. How do we go about dependency injection? Do we need middleware and interceptors like some of these other kind of things like this tend to have? And how does this actually play with some of these other libraries that we might be using? And so that's why I'm here, and I want to hear from you guys if you think this is something worth kind of building on. And if you've done similar things in the past, what's worked well, what hasn't, and what you'd like to see from something like this. And so to finish things off, I wanted to muse a bit about how this data-driven approach might pan out. In programming, as we better understand the problems that we're solving and kind of see what the boundaries of some of these problems are, we tend to end up with libraries or systems that we can use declaratively. And I think with web development, we're getting to a point where almost every subsystem and some kind of problem that we have when building applications now has a pretty nice declarative system that we can use to make our applications happen. And even things that might just be declarative and not data-driven, like let's say React or GraphQL, which are declarative, but the syntax you use isn't data. Well, we're Clojurers, and so we just slap on a Clojure interface on top of that is data-driven. And now we have a data-driven and declarative system. So I foresee that for a lot of web applications, many of the ones that we build will consist almost exclusively of a few of these components that we can configure declaratively and in a data-driven way. And so a lot of the programming will end up being just coming up with these declarative data structures and manipulating them to fit into those systems. So that's kind of one perspective. I need my application to do X, Y, Z, and here are these libraries that will do those things for me. And they use a data-driven API, so I need to figure out what data I need to pass to these libraries to make them work. But the more I do this, I realize that maybe there's an alternative perspective, kind of in reverse. Instead, what if we think about it as, hey, these libraries have figured out kind of what the stuff that we need to do is versus the stuff that's kind of incidental complexity, kind of the inherent versus the incidental complexity of our problems. So these data structures we can kind of think of as some of the fundamental concepts in our application, the kind of business logic or the domain model of what we're doing. And so we could represent what are these fundamental concepts in our applications, and then let's just manipulate them so that we get them into the libraries as we want. So instead of thinking, these libraries do what I want to do, what do I need to give them? Here's what I think I have in my system. Instead, how do I manipulate it to make the libraries work? So there's this cool library in Clojure called Hodor, which I think is a huge step forward in this direction. And it introduces syntax for describing entities. And then once you describe an entity, you can convert it to a datomic schema and a Licinia schema and specs and do visualizations on them. And I think it's very cool, and if you want to learn more about that, you can Google Hodor or check out Tiago's talk, who did most of the work on this, called Declarative Data Modeling. But I think entities, or types, if you're doing typed functional programming, aren't the entire domain model. Even entities and events aren't the entire domain model. I don't think you can describe most applications with just these two things. I think the other missing pieces include data views, or called queries or subscriptions, so like projections of the state in your system to various kind of sub-views. Various cross-cutting constraints, so things that you can't really describe just purely in types, and that might depend on the state of the system to decide when things can happen and when things can't. Primarily used in events, but maybe in other parts as well. And I also think permissions is important. Now, permissions, maybe you see it as kind of a subset of constraints, but most of the things we do, the reason we put an API in front of our database is because we want to establish rules about who can do what and when. And we typically want to have both kind of write time permissions. Can this user do this at this time in this way? And also read side. This user wants to view this thing, can they do that? But also, what subset of the thing that they're looking at are they allowed to see? Because very often, in a lot of interesting applications, you have more data about the thing in the system than a given user will have to see, or it has to be anonymized in some way or approximated. What does it look like to describe these things in a declarative, data-driven way? We have some ideas for entities and events. And there might be things from the libraries that are associated with each of these kind of concerns that might inform us into what's needed and what the syntax might look like. But a lot of these things are related, right? We saw that events kind of have specs on them, and so that can come from entities. And permissions probably might be implemented on top of kind of some sort of entity object as well. So which of the things are in common? What other subset things do we need to make this stuff happen and easy to use? And are these things even like that I've identified here, are they sufficient for us to kind of describe our systems? And I think these are all kind of open questions, but that's kind of my bigger vision for Tada is, right now it might be some tooling just to do some event stuff, but eventually perhaps it would give you the tools to represent the core domain in a purely declarative, data-driven way, and then also give you the tools and a collection of things that the community might write to help you turn those tools into actual implementation things using libraries and systems that aren't your own. So kind of that's the idea behind Tada. Is it worth doing? Kind of we'll find out. If this is something that interests you and you'd like to work on it, I am really open to working with other people. So let's talk, and I want to hear what you think. Thank you. Ta-da! Now, I was asked before, why is it called Tada? And my friend first thought it was because of that, but actually it was data, and let's manipulate it, and ta-da, get a system. So that's what that is. All right, any questions? We got one.
I'd like to ask, have you thought about making the conditions more transparent so they can be automatically described in docs? So instead of functions, using namespace keyword references to predicates or something like that with parameter references?
Yeah, no, definitely. So the idea there is like, those conditions right now, we just weren't sure so far how to really make them work in a nice way. But definitely, that was something I thought about because a bunch of them are shared between events. Like there are certain predicates that you do check across in a whole bunch of places. Right now, the way that kind of works is just like I tend to implement the predicates as like some helper function, but those predicates as we use them, it's not just the predicate, it's like the kind of error that entails and the message. So I think something like that where the predicate, the conditions are a top-level concern rather than just included as within an event. I think there's...
Hi. I got kind of stuck on your example of like the can question mark predicate, because if you think about the code that you had, you can't actually evaluate the conditions in the front end. Because if you look at them, they're using like private functions that might not be a kind of, you wouldn't want to expose by an API or anything.
I mean, I imagine that some of those things you could, and there could be a way to help you manipulate, like if especially we made those conditions be kind of declarative. I mean, I feel like a lot of the time they're purely based on client-side state, but in those cases, yeah, you're right. Like right now, out of the box, it doesn't cover all the situations if you do have like a super private thing that you would need to check. But you can imagine that maybe you inject the function in the front end that does it differently in the back end, and that function does then call the back end API, and the back end API does check it in some sort of way. I think like most things, like if a person can end up doing something or not doing something, to figure that out wouldn't necessarily involve, I think like in the majority of cases, wouldn't be a restricted thing to ask. And then so the question would just really be, how do you go about doing this so that you can do it from the front end to call the back end. But I think that's something that if you have the right amount of information, you can do and have it basically effectively kind of RPC or some other way over HTTP talk to the back end.
So what we ended up doing in one project was kind of turning this around. So when we return kind of, you get an object, you actually, that contains kind of the set of operations you can do on that object. And then we use that to hide and show UI elements. Because we're fetching the thing, we're merging all these things together, it's really easy to compute at the same time, you know what's possible. And then you don't need to actually duplicate the logic on the front end or anything.
Yeah, perhaps. Yeah, the reason that I was thinking that putting these things on the events is because I tend to find that a lot of the events are kind of cross-cut across objects, and there's not clearly like one place to put them. Like sure, for some things, yes, you know, the object might contain all the, or the entity that we're talking about might contain all the information to decide whether or not that thing can interact with it. But a lot of things might involve multiple entities, and so the only kind of, that's why like I almost think like all events in a system are a top-level thing, and not necessarily, like it's the special case that these events are attached to specific entities, and the general case is that they should just sit on the top level. But again, I love that kind of feedback, and this is the kind of stuff that we might need to help make this kind of more usable and more flexible.
Thanks.
Thank you.